Imagine a world far beyond Earth, a frozen moon orbiting the largest planet in our solar system, Jupiter. Beneath its icy crust, there could be a hidden ocean, vast and teeming with the potential for life. Europa, one of Jupiter's 4 largest moons, has fascinated scientists for decades. Could this frozen world, so distant from the sun, actually host life? We all know Jupiter as the largest planet in the solar system, a gas giant of immense size and power. But Jupiter isn't just remarkable for its size. It also boasts the strongest magnetic field in our solar system, a staggering 20,000 times more powerful than Earth's. This magnetic field is so intense that it creates a dangerous radiation belt around the planet, lethal to any spacecraft that lingers too long. Yet despite this hostile environment, Jupiter and its moons have drawn the attention of scientists for decades, particularly one icy moon, Europa. When you approach Jupiter, you'll witness its array of moons, each with its own story to tell. For example, Io, the closest large moon to Jupiter, is constantly erupting with volcanic activity. In fact, Io is the most volcanically active body in the solar system, with geysers of sulfur dioxide erupting from its surface. This constant outflow of sulfur enters Jupiter's orbit, contributing to its already dangerous radiation field. So why risk exploring this hazardous environment? The answer lies in one of Jupiter's most mysterious moons, Europa. This frozen world, with its icy surface and hidden ocean, may hold clues to one of humanity's greatest questions. Are we alone in the universe? NASA has launched the Europa Clipper mission, a spacecraft designed to investigate this enigmatic moon. The mission, which launched on October 14, 2024, has been carefully planned to avoid the dangerous radiation near Jupiter. By maintaining a calculated orbit, the Europa Clipper will sweep close to Europa multiple times without lingering too long near the planet's radiation belts. Europa is unlike most moons in the solar system. While other moons are covered in craters and scars from asteroid impacts, Europa's surface appears smooth and bright, coated in ice. This icy shell has captivated scientists for years because it suggests that something lies beneath, an ocean hidden from view. Many scientists believe that under Europa's thick layer of ice is a vast, salty ocean, potentially twice as large as all of Earth's oceans combined. This ocean, stretching beneath miles of frozen surface, might contain the conditions necessary for life. But how could such an ocean remain liquid, given that Europa is located so far from the Sun? Europa receives only a small fraction of the sunlight that reaches Earth, just 4%, and its surface temperature is a chilling minus 160 degrees Celsius. Any water on the surface would freeze solid. However, the ocean beneath Europa's ice remains liquid due to the tidal forces exerted by Jupiter's powerful gravity. As Europa orbits Jupiter, the immense gravitational pull causes the moon to stretch and compress, generating internal heat in a process called tidal flexing. This heat is enough to keep the ocean from freezing, despite the frigid temperatures at the surface. This phenomenon isn't unique to Europa. Other moons, such as Io, experience tidal flexing as well, though in Io's case, the heat generated by Jupiter's gravity fuels its volcanic eruptions. But on Europa, This process allows an ocean to exist beneath its icy crust, possibly creating an environment where life could emerge. Now, this raises an intriguing question. Could life really exist in such a cold, dark place? After all, Europa is far from the sun, and no sunlight reaches the depths of its hidden ocean. However, life on Earth has shown us that sunlight is not always necessary for survival. In the deepest parts of Earth's oceans, where no sunlight penetrates, life thrives around hydrothermal vents. These vents release hot water and minerals from beneath the ocean floor, providing the energy and nutrients needed to support entire ecosystems, even in total darkness. Scientists believe that similar hydrothermal vents could exist on the ocean floor of Europa. These vents could release heat and nutrients into the water, potentially providing the conditions for life to develop. On Earth, we find a diverse range of organisms living near these vents, from bacteria to complex creatures like tube worms and shrimp. While Europa's ocean is unlikely to host large, complex organisms, it could harbor simpler forms of life, such as bacteria or single-celled organisms that thrive in extreme environments. The Europa Clipper mission is not designed to land on the moon's surface or drill through its ice. Europa's ice shell is thought to be several kilometers thick, making it nearly impossible to reach the ocean beneath. Instead, the spacecraft will fly by Europa 49 times over the course of its mission, using its instruments to map the surface and gather data about the moon's icy crust, magnetic field, and possible water plumes. These water plumes, which could be jets of water vapor erupting from beneath the ice, may offer a glimpse into the ocean below without the need for drilling. While Europa Clipper won't directly search for life, its findings could provide crucial evidence about the moon's habitability. For example, if the spacecraft detects organic molecules or traces of water in the plumes, it would suggest that Europa's ocean might have the ingredients needed for life. Even more exciting, the mission could uncover signs of active geology, such as ongoing volcanic activity beneath the ice, which could provide additional heat and nutrients to support life in the ocean below. One of the major challenges in exploring Europa is the intense radiation from Jupiter's magnetic field. Any spacecraft that spends too long near the moon risks being damaged or destroyed by the radiation. That's why Europa Clipper has been designed to make quick flybys, minimizing its exposure to harmful radiation. Despite these precautions, the mission will be able to gather detailed data about Europa's surface and subsurface, helping scientists to build a more complete picture of this intriguing world. The mission is expected to reach Jupiter and Europa in 2030, with the first detailed mapping of Europa taking place in 2031. Over the course of 4 years, the spacecraft will complete its 49 flybys, providing us with the most detailed view of Europa ever obtained. By 2035, we may finally have answers to the questions that have intrigued scientists for decades. Could life exist beneath Europa's icy crust? Could this frozen moon be one of the few places in our solar system capable of supporting life? What do you think? Please leave a comment.